Recording. So the topic is introduction to matrices. Okay, a matrix is a collection of objects in row and column format. There can be multiple rows and multiple columns. Okay, for example, this is a matrix. Okay, so the horizontal rows are two. Rows are always horizontal. Okay, and vertical columns are four. Vertical columns are four. Okay, so 2 by 4. 2 by 4 becomes the order of the matrix where 2 is M and 4 is N. So order of the matrix is M cross N, M cross N, where M is the number of rows, and rows are always horizontal, and N is number of columns. Columns are always vertical. So M cross N. This is M cross N. Okay. Now, if you multiply this, the answer will be 8. That means there will be 8 objects into this matrix. 8 objects into this matrix. So this is the first basic that you need to know in matrices. The first basic. Okay. That is the order of the matrix. That is M cross N. And if we multiply number of rows and number of columns, we'll get a total objects within the matrix. Now matrix is always denoted with the numbers are arranged in such a way that we use a box bracket. Okay. In determinants, we use this. Okay. Determinants is this. Okay, now first of all, don't get confused between the determinant and the modulus. Okay, so modulus is for a single number. Determinants we did last year. So you know what is a determinant. Okay, a determinant can be solved. Okay, guys, so a determinant can be solved, but then a matrix cannot be solved. So we cannot solve this matrix. It will remain as it is. So that's the first difference between a determinant and a matrix that you should know. Types of matrices. Types of matrices. You should know the different types of matrices. Okay. First one, row matrix. It has a single horizontal row. Columns can be anything. Columns can be any number of columns. So the order of this matrix is one row and three columns, one single row and three vertical columns. Okay. One single row and three vertical columns. The order of this matrix, one single row and four multiple columns. One single row, one horizontal row and four vertical columns. The order of this matrix is 1 cross 1. Okay, one row and one column. So technically this matrix is row as well as a column matrix. It's also called as a singleton matrix. A singleton matrix is the matrix which has order 1 cross 1. It is row as well as a column matrix. Okay. Yeah, we'll proceed further. I hope everybody has copied this. Second one, column matrix. It has a single vertical column. Okay. So the order of the first matrix is three rows, three horizontal rows. Okay. And one vertical column. 3 by 1. Second matrix, two horizontal rows and one vertical column. Third one, 1 by 1. So this particular matrix is row as well as a column matrix. It's a singleton matrix. It has only one object. Okay. So a column matrix has a single vertical column. Now we'll proceed with a null matrix. Null matrix. So it's capital O or zero also. Okay. Right. So the order can be anything. The order can be anything, but then not even a single object will be non-zero. Every single object will be zero. You will not find any other object apart from zero. So individual objects are zero. That's a null matrix. That's a null matrix. Okay. Then the fourth one, square matrix. Square matrix. In a square matrix, these are the examples of square matrix. Number of rows equal to number of columns. Number of rows equal to number of columns. So this is 2 by 2. This is 3 by 3. This is 1 by 1. Two rows, two horizontal rows and two vertical columns. Here it will be three horizontal rows and three vertical columns. Okay, and here is one horizontal row and one vertical column. Fine. So that is a square matrix. Okay. Number of rows will be equal to number of columns. Fifth one, diagonal matrix. Diagonal matrix. Okay. First of all, diagonal matrix has to be a square matrix. It is a square matrix. It should be a square matrix. But then this is a very special square matrix. Okay. Now this is a diagonal. For your syllabus, this is the diagonal. So the diagonal elements can be zero or non-zero. यहाँ पे zero भी हो सकता है. Okay. In the diagonal. But then the non-diagonal elements, these are the non-diagonal elements, the one in green, they have to be zero. वो zero ही रहना चाहिए. Diagonal element zero भी रह सकता है, non-zero भी रह सकता है. But then non-diagonal elements have to be zero. One more example. It's a square matrix. This is a diagonal. So the diagonal elements are zero or non-zero. But then the non-diagonal elements are compulsorily zero. Compulsory. You will not find any other object. Even if one object is non-zero, for example, one over here. So it's a square matrix. It's not a diagonal matrix. Okay. And in a diagonal matrix, one thing is for sure that it has to be a square matrix. Next one, scalar matrix. So it is a square matrix. It is a diagonal matrix, but then it is a special kind of square and diagonal matrix. Diagonal elements are same number, same. And since it is a diagonal matrix, non-diagonal elements will be zero. Is this a diagonal matrix? Is this a diagonal matrix? The answer
Yes.
is yes. Because the diagonal elements are same, the non-diagonal elements are zero. Okay. And if even if one number is like this, -1 +1 -1. So it's not a scalar matrix. It's not a scalar matrix. Okay. It is only a diagonal or a square matrix. Okay. The diagonal elements will remain same. Then only it is a scalar matrix. Okay.
So,
Next one is ha.
in scalar matrix, the signs should be the same as well as the numbers.
Yes.
Okay.
Seventh one, identity matrix. It's a square matrix. It's a diagonal matrix. It's a scalar matrix. All three. But then the diagonal element is compulsorily one. Diagonal element is one. Okay. Then only it is a identity matrix denoted with capital I. Denoted with capital I. Denoted with capital I. Okay. Denoted with capital I. Fine. So that's the identity matrix. Okay. So now identity is scalar, diagonal, square, all three categories, but then it's a very specialized scalar because the diagonal element is one. Okay. So it is scalar as well as identity. Yeah. Next one, upper triangular matrix. First of all, it is a square matrix. It's a square matrix. So it forms a upper triangle like this. Only this element will be zero. Within the pink colored part, it can be zero or non-zero. It has to be a square matrix first of all. In the pink colored part, this is a triangle formation. This will be zero or non-zero. But then this three will be zero. So these are the examples of upper triangular matrix.
Sir, I have a question.
Yeah.
Sir, in the textbook, the example they have given, even the 3 in the center is a 0. Is that also still upper triangular matrix?
Come again.
In the textbook, when they've written upper triangular matrix, they're explaining it. Even the 3 in the center is a
Ah,
0. That is
correct. See,
okay?
this is also zero, na? This is also zero.
Okay, sir.
So what I'm saying is only the pink colored part, that triangle you focus on, in that pink colored part over here, let it be zero or non-zero.
Okay, sir, understood.
Okay. But then those down bottom zeros, this three will are supposed to be zeros. Okay. Yes. Now lower triangular matrix. This is an example of lower triangular matrix. Okay. So this is a lower triangle. These things should be zero. Now this is a square matrix as well. It's a square matrix. Okay. Upper triangular is required in some of the cases. Lower triangular hardly you will, require in any of the problems in the chapter. Okay. Now comes a very important part. Solving a determinant. Let's get back to determinant which we had studied in grade 11. 2 minus 1, 6, 4. So the answer of this is this into this. 2 into 4 minus 1 into 6 over here. So 8 plus 6, which is 14. This is a solving of a 2 by 2 determinant. Please try and understand this is not a matrix, this is a determinant. This is a determinant. Okay, now a 3 by 3 determinant. Okay, so how to solve this? Plus, minus, plus, plus, minus, plus, plus, minus, plus, 3 round brackets and 3 2 by 2 determinants. We have to consider the first row. So 2 will come over here. Then minus 1. Minus 1 will be written over here. 3. Sorry, minus 3. Minus 3 will be written over here. So that's how we fill up the round brackets. So it is always plus, minus, plus, 3 round brackets and 3 2 by 2 determinants. Okay. So 2 is over here. This 2 is over here. Okay. So ignore that row, ignore that column. 1 4 1 minus 1. Minus 1 is over here. Ignore that row, ignore that column. 2 4 0 minus 1. Then minus 3 is over here. Ignore that row, ignore that column. 2 1 0 1. 2 1 0 1. Okay, let's solve this. 2 box bracket plus 1 because minus into minus is plus. And this is minus 3 plus into minus. So 1 into minus 1 is minus 1 minus 4 into 1 is 4. Bracket minus bracket. 2 into minus 1 is minus 2. 4 into 0 is 0. 2 into 1 is 2 minus 1 into 0 is 0. So 2 into minus 5. You have every possibility of making an error over here. And errors occur when you take shortcuts. Plus 1 into minus 2, and error can happen by anyone. It occurs at any point. Okay. Unintentionally. So you have to be very careful over here. So solve this, you'll get the answer. Okay. Answer is immaterial. I'm not bothered about the answer. I'm just concerned about the method to solve a 3 by 3 determinant. Method to solve a 3 by 3 determinant. Okay. So this is how you solve. I'm very sure those who have learned from me last year determinants, I have taught you this method. New students, I don't know whether you were aware of this or not. Yeah. So after lower triangular matrix, I'll take you to a very special matrix that is called as a singular matrix. Singular matrix. First of all, it's a square matrix. Okay. Matrix A is singular. if its determinant is 0. Okay. For example, so this is matrix A. Let this be matrix A. We'll find out the determinant of this matrix. Bracket minus bracket. 1 into minus 1 minus 1 minus 1 into this minus 1 is minus 1. Is the answer 0? The answer is 0. Determinant of this matrix is equal to 0. Now, since the determinant of this matrix is equal to 0, okay, I will say matrix A is singular. And it is not necessary that every time they will give you a 2 by 2 matrix. They might also give you a 3 by 3 matrix. They will also give you a 3 by 3 matrix. They might. So if we are supposed to prove whether a matrix is singular or not, okay, then we need to find out its what?
Determinant.
We are supposed to find out its determinant. So that's the reason why I was teaching you 2 by 2 determinant and 3 by 3 determinant. That's very important for the chapter. I hope everybody has copied this. Yeah. So next one, let's understand a concept which is called as transpose of a matrix. Just a second. Yeah. So a new concept which is called as transpose of a matrix. Now suppose matrix A is this. Okay. The order of this matrix is 2 horizontal rows and 3 vertical columns. Okay. Now A transpose. First row will become first column. Second row will become second column. First row becomes first column. Second row becomes second column. The order of this matrix will be 3 horizontal rows and 2 vertical columns. 3 horizontal rows and 2 vertical columns. Okay. So this is the concept of transpose. And to find out the transpose, it is not necessary that the matrix has to be a square matrix. You can find out transpose of any matrix with any order. So this is transpose of a matrix. So AT or A dash, it is denoted with AT or A dash. It's nothing but transpose of a matrix. Transpose of a matrix. Okay. Now the next concept after singular is symmetric matrix. Okay. If A is equal to A transpose, then A is symmetric. If A is equal to A transpose, then A is symmetric. Example. This is matrix A. A transpose. First row will become first column. Second row will become second column. Third row will become third column. Now you guys tell me, is A equal to A transpose? Is this true or false?
True.
Are both same?
True.
Yes. Yes, both are same. So if both are same, then A is symmetric. A is symmetric. If A is equal to A transpose, then A is symmetric. Okay. And the last category after this, that is skew symmetric matrix. If you have copied this, I'll take you to skew symmetric matrix. There is nothing called as anti-symmetric or non-symmetric. Okay. Skew symmetric matrix. If A is equal to negative A transpose is equal to negative A, okay, then A is skew symmetric. Example. Okay, so this is A. We'll find out A transpose. First row will become first column. Second row will become second column. Third row will become third column. Okay. Now you guys tell me, are both same this time? Is this and this same?
Signs are different.
Signs are different, correct. So from the entire matrix, I'll take minus sign common. Now this thing doesn't happen in a determinant. You cannot take one negative sign common from the entire determinant, okay? So I've taken negative sign common from the entire determinant. So this is equal to minus 0. Minus 1 will become 1 because minus has gone outside. I've taken minus outside, but there is no minus for this 2. So I'll make this minus 2 because this minus into this minus will be this plus over here, okay? So change the signs within the matrix. Change the signs within the matrix when you take minus sign common. So this is negative. Now this part, is it equivalent to this? This and this, are they equal? Forget about the minus sign which is outside. I'm just asking this part. This part. Is it equivalent to this?
Yes.
Yes, sir.
That's equivalent. The values are same. So A transpose is equal to negative A. Therefore, A is skew symmetric. Therefore, A is skew symmetric. So you should know this particular category. Okay. Now, next thing that we are proceeding with is algebra of matrices. Algebra of matrices. Algebra of matrices. Okay. First, addition, subtraction. Addition, subtraction. Okay. Two matrices can be added or subtracted only if their orders are same. For example, are orders of both the matrices same?
Yes, sir.
That's 2 by 3. So the corresponding elements will be added. So 2 will be added to this 0. You cannot add this to this 4. These are not corresponding elements. Same position elements will be added and subtracted. So this is 2. 1 plus 1. This is also equal to 2. 6 plus 2, 8. Okay. Likewise, 0 plus 4, that is 4. 1 plus 1, that is 2. 2 plus 3, that is 5. So the corresponding elements are added or subtracted. Corresponding elements are added or subtracted. Okay. Only if the matrices order is same, the order of this matrix and this matrix is same, then only we have to do this. Otherwise, we cannot. Now, if there is a minus sign in between, so we have to subtract these elements. Okay. 2 minus 0, that is 2. 1 minus 1, that is 0. 6 minus 2, that is 4. 0 minus 4, that is minus 4. 1 minus 1, that is 0. 2 minus 3, that is minus 1. Okay. That's it. So this is addition and subtraction. This is the first operation, algebra of matrices. Second operation. Second operation. Second operation is scalar multiplication. Scalar multiplication. There are two multiplications. First one is scalar and the second one is matrix multiplication. So scalar multiplication. Suppose A is equal to 161205 and they're asking you 2A. So 2A will be 2 multiplied the entire matrix. Whatever matrix is there, you have to multiply 2 with it. So each and every object will be multiplied with 2. 2 into 1, 2, 2 into 6, 12, 2 into 1, 2, 2 into 2, 4, 0 and the last one will be 10. Each and every object will be multiplied with 2. Okay. So this is called as scalar multiplication. If you are multiplying this with minus 2, okay, so multiply each and every object with negative 2. The answer will be negative over here. 0 will remain 0. 0 does not have any positive or negative sign. This is scalar multiplication. Okay. Scalar multiplication. There is a difference between matrix multiplication and scalar multiplication. Okay. Matrix multiplication, it's very complicated. If there are two matrices A and B, okay, we cannot really multiply anyhow. That is point number one. Scalar multiplication was pretty simple. Multiply a number with a matrix, that was absolutely very simple. But then when we multiply two different matrices, the complications will start. So now understand, if the order of A is 2 cross 3, 2 rows and 3 columns, if the order of B is 3 cross 1, okay, if the columns of the first matrix is equal to row of the second matrix, then only we can multiply A and B. Then only we can multiply A and B. Otherwise, we cannot. In this case, it is same. Yes, so we can multiply. So whatever answer is there, when we combine these two matrices, how to multiply that I will teach you. Once you get the answer, the resultant matrix, the answer will have the order 2 cross 1. Will have the order 2 cross 1. Guys, did you understand this?
Yes, sir.
Yes.
So the rows columns of the first matrix, column of the first matrix should be equal to the rows of the second matrix. The rows of the second matrix. Now I'll share some examples. This is just for your understanding. The order of this is 2 cross 3, and this is also 2 cross 3. Can we get the answer?
No, sir.
No, sir.
We cannot really get the answer because these numbers are not matching. These numbers are not matching. Okay. Second case. Can we get the answer?
Yes, sir.
This and this, yes, it is matching. What is the order of the final answer?
2 by 2.
2 by 2. Okay. One more case. This is 2 by 1. And this is 2 by 5. What will be the order of B?
1 by 5.
Correct. So 1 will come over here, cross, and this 5 will be over here. Okay. So this is quite logical. One more case. One more case. 3 by 4. 2 by 4. Order of this.
3 by 2.
That's correct. 2 will be over here. And this 3 is over here. So they can ask you this kind of things in objectives and MCQ. Yeah. Next one. Now let's understand the process of this. Let us understand the process of this. The order of the first matrix is 3 by 3. 3 horizontal rows and 3 vertical columns. 3 by 3. Okay. The order of this is 3 by 2. So can we multiply these two matrices?
Yes, sir.
Yes. You may multiply these two matrices. Understand the process. Understand the process. For the first matrix, draw these 3 lines. For the second matrix, draw lines which are vertical. So for the first matrix, draw horizontal lines. For the second matrix, draw vertical lines. Now, some students might know this, but then still you can pay attention to this. First row, first column. 6 into 2, 12. Plus, the row is not over, the column is not over. 2 into 1, 2. Plus, the row is not over, the column is not over. 4 into 0, 0. The row is not over, the column is not over. Now the row is over, the column is over. First row, second column. So leave some space over here. 6 into 1, 6 plus 2 into 1, 2 plus 4 into minus 1 is minus 4. Okay. I'm going to repeat this entirely once again. Again, I'm going to repeat this. First row, first column, then first row, second column. Then go to the next row. Second row, first column, second row, second, likewise. 6 into 2, 12 plus 2 into 1, 2 plus 4 into 0, 0. Okay. First row, first column is over. Now first row, second column. 6 into 1, 6 plus 2 into 1, that is 2 plus 4 into minus 1, that is minus 4. Okay. Now first row and both the columns are over. Second row, first column. 3 into 2, 6 plus 2 into 1, 2 plus 1 into 0, 0. First row, first column is over. Now first row, sorry, second row, first column is over. Second row, second column. 3 into 1, that is 3 plus 2 into 1, that is 2 plus 1 into minus 1, that is minus 1. This part I leave it up to you. This you will know what is the answer. Okay. That I'll just leave it up to you. Okay. Don't go wrong in bottom mass and all. That's it. Fine. Second row, second column is also over. Third row, first column. 0 into 2, that is 0, plus 1 into 1, that is 1, plus 0 into 0, that is 0. Okay. Third row, third column. 0 into 1, that is 0, plus 0 into 1, that is, sorry, 1 into 1, that is 1, plus 0 into minus 1, that is 0. You should not remain at the same object. You have to go ahead. Okay. For example, one iteration I will just show you once again. The third row, second column. Okay. So third row, second column. 0 into 1, that is 0. Plus, don't remain at 0 and 1. You have to proceed with the next object in that row and in that column. 1 into 1, that is 1, plus 0 into minus 1, that is 0. So this is how you will get the answer. Okay, this is how you get the answer. Only for this problem, I'll just solve and show it to you. This is 14, this is 8, and this is 1. 8 minus 4, that is 4. 5 minus 1, that is 4. And this is 1. So the resultant matrix is having the order 3 by 1. Okay. This has to be 3 by 1 because see, this is 3 by 3. This is 3 by 2. Sorry, I said 3 by 1. It is 3 by 2. 3 by 2. That is the order of this matrix. Those who understood this calculation, please let me know.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, next example. The order of the first matrix is 2 by 3. 2 horizontal rows, 3 vertical columns. Two horizontal rows. I think I should make it 3. Sorry. 3 horizontal rows and 1 vertical column. Now we can multiply these two matrices. Put these arrows over here. Put these arrows over here. First row, first column. 1 into 2, that is 2, plus 2 into 0, that is 0, plus 3 into minus 1, that is minus 3. Now first row, first column is done. There is no other column in the second matrix. Okay, so there won't be any space like this. The calculation ends over here for the first row. Okay, because in the second matrix there is only one column. Now second row, first column. 6 into 2, 12, 0 into 0, 0, 1 into minus 1 is minus 1. 2 minus 3 is minus 1. 12 minus 1 is 11. Okay. Yes. Let me know whether you have understood this or not.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
One last example based on this. Last example based on this. This is 3 by 3. This is also 3 by 3. This number is matching. So the answer will also be 3 by 3. Okay, so we can multiply this. But this time I am expecting answers from you. 3 horizontal rows over here and 3 vertical columns over here. Okay. Yeah. So first row, first column. Tell me the calculation of first row, first column. I don't want the final answer. I want how you will calculate.
1 into 1 is 1.
Correct.
Plus 2 into 6, which is 12. Plus
Plus.
3 into 4, which is 12.
Correct. Good. Very good.
Then you do 1 into 0, which is 0.
Correct. Now let me ask you one thing before that. Should we go to the next row or should we continue with the same row?
Same row, but you leave space, so it's a different column.
Perfect. We have to continue with the same row because first row along with first column is done. Now first row along with the second column.
Second column.
That's why we need to leave some space over here. Good amount of space. Space as in don't write over here. Okay. Yeah. So
1 into 0 is 0.
2 plus 2
2
into
into 2
2
is 4.
plus
3 into minus 2 is minus 6.
perfect. Again space. First row, third column. 1 into
1
1.
into 1 is 1. 2 into -1 is -2. And 3 into 0 is 0.
3 into 0 is 0. Okay. Yes. Now for first row, all the three vertical columns are over from the second matrix. For the first row from the first matrix, all three columns are over from the second matrix. Now, second row, first column. Yes, anyone else can try this out, please. Come on, speak up.
So 4 into 1 is 4,
Correct.
plus 5 into 6 is 30, plus 6 into 4 is 24. Now same row we leave some space and we do 4 into 0 is 0.
Correct. Second row, second column.
Yes, sir.
4 into 0 is 0. Go to the next
5
object.
into 2 is 10. Plus 5 into 2 is 10. Plus 6 into -2 is -12.
Correct. Second row, third column.
4 into 1 is 4. Plus 5 into -1 is -5.
Good.
And 6 into 0 is 0.
That's the calculation for the second row with all the three columns on the right hand side matrix. Someone else? Come on. Start.
So the first is 1 into 1, which is 1, 2 into 6, which is 12, and then 1 into 4, which is 4.
Okay. Then
Then it is 1 into 0, which is 0, 2 into 2, which is 4, and then 1 into -2, which is -2.
perfect.
And then it is 1 into 1, which is 1, 2 into -1, which is -2, and 1 into 0 is 0.
Solution part you can do it at home. The final answer of this. But then yes, how to solve? It should be absolutely very clear. Those who are copying, please copy quickly. Yeah. Good. The order of the first matrix is one row, one horizontal row, and three vertical columns. Rows are always horizontal. Order starts with row. And this one is three horizontal rows and one vertical column. This number is same. So the final answer will have a singleton matrix because the order is going to be 1 cross 1. 1 cross 1 मतलब एक ही ऑब्जेक्ट रहने वाला है. Yes, someone else, can you try? Horizontal row over here and vertical columns over here. Then there is a single vertical column. Start. Come on, tell me. Someone else, please try.
Sir,
Try. Come on.
so 6 into 1, 6.
6 into 1, 6.
plus 1 into 2, 2,
Correct.
plus 0 into 3, 0.
So the answer is going to be a singleton matrix and that object will be 8. The order is 1 cross 1. Now we are going to understand mapping. We are going to understand mapping. Be ready for that. So this was matrix multiplication, multiplication of two matrices. Okay, so matrix multiplication. I'm sorry, mapping. Okay. Let us understand the mapping table. How many rows are there? How many rows are there?
2 rows.
There are 2 rows. Row number 1, row number 2. How many columns are there?
3.
3 vertical columns. 2 horizontal rows and 3 vertical columns. Okay. So this object, the code for this object is A11. First row, first column. And small a is what we denote the number with. So small a11 is 2. Small a11 is 2. The second code, first row, second column. Small a12. Always first the row, then the column. First we have to write down the row and then the column. One three. So a13. So a13 is equal to -3. So this position is a13. This will be a21 and a21 is 6. This will be 822, second row, second column, and A23. So this is the mapping table. This is the mapping table. This is the mapping table. Understood?
Yes, sir.
Okay. One more example. Acha, by the way, small a11 is 2, small a22 is 4, a13 is -3. It will be the corresponding element. There are only 2 rows. There are only 2 rows, 2 horizontal rows and 1 column. So what is the code for this? A11. First row, first column. Can someone tell me the code for this?
A21.
A21. Second row, first column. Second row, first column. Okay. One last question that will be the end of today's session. Find matrix A ij. Find matrix A such that small aij is equal to modulus of I plus 2j, or rather I'll take I minus 2j. Find matrix A such that aij is equal to modulus of I minus 2j and of order 3 by 2 and of order 3 by 2. Just copy the question clearly. Now, first and foremost, they have given us the order 3 by 2. So first we'll make the mapping table of 3 by 2. 3 rows and 2 columns. Come on, tell me what is the value of this? The code value. Not the object value,
A11.
but then what is the code value? This is small a11. What is of this?
A12.
Good. Row and column a12. A21, A22, 31, 32. Okay. So what is ij? I'll tell you what is ij now. This is I, this is j. The first object is, the first number is I, the second number is j. Row number, column number, row number, column number. So the row number is I, column number is j. So first we are going to calculate A11, this object. A11 equal to modulus, okay, I minus 2j. When I say A11, who is I and who is j?
I
Who is
is
I
1
and who
and
is
J is 1.
good? This is I and this is j. So 1 minus 2 into 1. 1 minus 2 is minus 1. Modulus of minus 1 is 1. Okay. So this is 1. That's the final presentation. A11 is 1. A12. A12. Guys, tell me who is I and who is j?
I is 1, J is 2.
I is 1, j is 2. 1 minus 4 minus 3, modulus of 3 is 3. Modulus of minus 3. So this object is 3. A21. A21. The next calculation will be A21. Guys, what is I and what is j?
I is 2, J is 1.
First object is I, second object is j. I is 2, j is 1. So this is 0. Modulus of 0 is 0. Yes. All boys, please calculate this A22 and tell me the answer.
Equals to 2.
Sorry,
2.
other boys are not there.
Yeah, it's
Is
true.
your answer matching? If anybody wants me to calculate, I'll just calculate it for you. The answer is 2, and that's correct. Girls, preferably everyone reply. So all girls, A31. What is the answer? The final answer of A31. Method I have taught you.
1.
Correct. Others, are you getting the same thing? 1.
Yes, sir.
Yes,
Yeah.
sir.
This is 1. A32.
One.
This is
Yeah,
also
it's
1. Okay. A32 is also 1.
Sir, isn't it -1?
But then what is the modulus of -1?
Oh, yes, sir. Sorry, sorry.
No problem. So in your textbook, this kind of problems are there. They can give you any formula over here. I have just made up anything from my mind. They can give you any formula over here. Random thing. Method remains the same. Mapping table should be written first. Mapping table, please. That's very important for the rest of the chapter. That's why I took it very slowly, the mapping table and the problem related to it. That is the end of today's session. Just wait.